you have studied asymptotes before. You know about asymptotes. We're looking at this from a different perspective. We're making a connection with calculus methods that you have learned previously in this course, and how we can move forward, particularly in the curve sketching area. Okay? Before we start talking about asymptotes and asymptotic behavior, what is an asymptote? Does anybody know what the definition is? I don't want a formal definition necessarily, but what's an asymptote? Molly?
A value of x that the function will never reach.
No. Well, maybe. It could. It could be a value of x. It could be a value of y, depending whether it's horizontal or vertical. Because I was thinking of horizontal when you were talking about x. I thought, oh, it could be x for... let's just say this. A line that a function approaches but never crosses. And I put the ... because with every rule there is an exception. Okay? And I'm just going to show you what I mean. Let's pretend there's a horizontal asymptote. It's possible for a function to do this. Ooh, look. The function actually crossed the asymptote. But at the extreme ends, at the extreme values, as x approaches positive infinity, it becomes an asymptote. Okay? It's quite clear right here that the function actually crosses the asymptote, but for horizontal asymptotes, we're really looking at the behavior as x approaches negative infinity or positive infinity. Okay? So when we talk about that an asymptote is a line that the function approaches but never crosses, really at the extreme values. Okay? And of course, we know that that's not going to be true for vertical asymptotes, because if it crosses a vertical asymptote, then it's not a function. If it crosses vertical asymptote, it might not be a function because it crosses twice. Vertical asymptotes. How do you know when a function has a vertical asymptote? Arian. Okay. First of all, you have to know that they're for rational functions, right? So it's when the denominator equals 0, did you say? And the numerator does not. And the numerator does not. In simplified factored form. Because if the denominator equals 0 and the numerator equals 0, we can divide those, we will be able to divide those out, those polynomials out, those expressions out. Okay? So it's vertical asymptotes for rational functions. Okay? At least in the restriction that we're doing. I mean, when we get into trig functions and all these other things, there may be vertical asymptotes. And always, okay. Horizontal asymptotes. I don't have enough room to write down stuff for that, but that's okay. You can scribble it down if you're listening to this on on the recording, you can write this stuff down. Horizontal asymptotes also occur for rational functions, and they will occur when the denominator is of equal order or higher order than the denominator. When the denominator is equal order or higher order from the numerator. So if we have an x, the highest order in the numerator is an x, we have to have an x or an x squared in the denominator. Okay? If we have an x cubed in the numerator, we have to have at least an x cubed or an x to the power 4 in the denominator to have a horizontal asymptote. Or anything above, at least. Equal or, okay? Now, if the denominator is of less order, that's when we get these oblique or slant asymptotes. You studied that in HF. When you did polynomial division, you could get the equation of that oblique asymptote line. We're not doing that in this course. I mean, we could, but we're not going to. Okay? In university, when you study this sort of cursor heads and stuff, that will probably be thrown in and you need to be aware of it. But you need to be aware that I won't ask you that sort of stuff. Okay? Some of you look confused. When I talk about higher order, I'm talking about the value of the exponent. Okay? If you have x squared, it means the order is 2. Okay? If you have x, the order is 1. For oblique asymptotes? Sure. Y is equal to 2x squared plus 7x plus 101 divided by x plus 92. I'm just picking numbers I know won't factor. It won't factor and divide out. The numerator is of higher order. That will have a slant or oblique asymptote. If you do the division, you will get the, when you do the division, you will get the equation in the form y equals mx plus b. Yes? Rational function is a function that looks like a fraction, where you've got variables in the numerator and the denominator. That's what a rational function is. Sorry, you don't have to have a variable in the numerator. You know what, Alex? I don't know. Honestly, in all my years of teaching calculus, we've just avoided it for whatever reason. I've literally taught it maybe once, and I just did it in a very low level, very superficial way, and always did it one way. So I can't answer that question, unfortunately. Okay. Give you a chance to write that down. Go again. Okay, so when you see this example, what immediately pops in your mind? Factor. Absolutely. Absolutely. Why? Factor first, factor first, factor, factor first. Now, I like to put it in brackets because it organizes my brain, that I can see them as distinct things that I can't cancel anything. Cancel is when a TV show no longer exists. That's being canceled. Divide them out. Y is equal to 1 divided by, I actually don't want the brackets anymore, x minus 3. Beg your pardon, Taylor? Well, I don't need a limit yet. What I need to do is this. I'm explaining what I'm doing. This is part of your solution, okay? If you want to lose marks, don't put all the pieces of the puzzle in, okay? Vertical asymptote. VA, vertical asymptote. Vertical asymptote, what up? No. No, because the question asks us about vertical asymptotes. Doesn't ask us about discontinuities or anything else. Okay? Now, I know this is silly for this part because you're all grade 12 and you get, oh my god, come on. But it's kind of it's just my structure, right? Just, I'd like to get used to it. Yes? Vertical asymptotes set denominator equals 0. That's where we'll get our vertical asymptotes. No, that's where the vertical asymptote is. The vertical asymptote is x equals 3. Okay. I know, but I'm also explaining, Molly. So when you ask a question, I get to explain to everybody who might have the same question. Did you know that this is the equation of a line? X equals 3 is the equation of a line. It happens to be a vertical line. Oh my god, vertical asymptote, vertical line. The connections just keep coming. Now, this, I'm going to scroll down here for a second. This means that when I go to sketch it, x equals 3. Okay? That's my sketch later on. I know it's going to look like that. Okay? Now, the space in between is for this idea of the asymptotic behavior. And what I mean by asymptotic behavior is, what's the function doing on either side of the vertical asymptote? So how are we going to figure out what's happening just on either side of the vertical asymptotes? Nothing? How do we do that? Sorry? One-sided limits. Thank you. We're going to do one-sided limits. Because, you know why? It's calculus, baby. It's calculus. Look, it's a connection with calculus. Please remember, I'm showing you this stuff. This is in your notes. We're going slowly so that you absolutely get it. The limit as x approaches 3 from the negative side of 1 over x minus 3 equals, listen, we've done this before. I don't want you to guess. I prefer you show your work and your understanding. When x is a little bit less than 3, 2.9999999999999, the denominator is going to be a negative number, and it's going to be very small. Note Mr. Hargraft's unique style, a negative sign in VS. Okay? It's not US. It's not us. The answer is going to be negative infinity. Because 1 divided by a negative number is a negative number, but 1 divided by a very, very small number is a very large number. There we go. There's one-sided limit. The limit as x approaches 3 from the positive side, 1 over a positive number that is very small, and that equals a positive number that is very large. I always, for some bizarre reason, always write down plus infinity or negative infinity. I don't know why I do it. Don't ask. I said don't ask. There's our asymptotic behavior, which means this. This is what it looks like. As we approach 3 from the negative side, we're approaching negative infinity, so it curls down like that. As we're approaching from the positive side, it approaches positive infinity, which means it curls up like that. Okay? Again, this is a piece of the puzzle. Once we get everything together, we'll be able to make a continuous sketch of what the function really looks like, but we're just looking at asymptotic behavior. Read the question. If you're given a quiz, and I ask you for the asymptotic behavior, I want a sketch that looks like this. Okay? Question, Ellie? No, no, no. I just want the asymptotic behavior. And, no, that's a sketch of the asymptotic behavior. If I started doing something like this now, There. Now I'm sketching the rest of the graph and the function.
You don't want us to just say it construct.
Correct. Okay? And I'm just going to go back up to the words here for a second. Determine the vertical asymptotes, which we did, x equals 3. The asymptotic behavior. We did that with the one-sided limits. Sketch the function near the asymptotes. So in this example, we've done those 3 things. Okay? Great. Yes? If we read the question, it clearly states vertical asymptotes. Okay? If I gave you a quiz tomorrow and said, find all asymptotes, determine all asymptotic behavior, sketch the function here, all asymptotes, then yes. But we're just doing one thing at a time. Okay? Okay. We'll get to the horizontal later. Don't worry. We'll get to the horizontal later. I was waiting to write this down. No, I looked at you with a positive, supportive, professional look on my face. What are we going to do? Factor. Now, I'm going to tell you now. I'm going to tell you now that when I give you a rational function like this, either the denominator does not factor, okay, so there will be no vertical asymptotes. I'm not going to give you one where you have to use the quadratic formula and get that x equals 2 plus or minus the square root of 7 over 2. At least I hope I don't. That's not really what I want to do. How does the bottom factor? X plus 6, x minus 1. Okay, now here comes the dull, boring part, which, I mean, as we do this over and over again, you're going to think, man, we have to keep doing this over and over again. Listen, the test is 2 questions. If you miss this on the test, you miss marks. Therefore, x plus 6, x minus 1 is equal to 0. Therefore, x equal to minus 6 and positive 1. Again, just trying to show you that it's a full solution. Yes? The derivative function has nothing to do with the asymptotes. We will not be worried about sketching the derivative function with asymptotes. No. The point of this whole unit is... I'm just waiting for everybody to stop talking because no. You should be sorry. Everybody who's talking should be sorry. The whole point of this unit is to do curve sketching. But this part has nothing to do with the derivatives. Okay? Just like when we put it all together and I asked you for the intercepts. The x and y intercept has nothing to do with calculus. Right? You can find x and y intercepts without knowing anything about calculus. You can do the asymptotes without knowing anything about calculus. But this idea of asymptotic behavior, we're doing is a little bit new. We're putting the calculus spin on it.
But will, like, say we derive that function.
It has nothing, but when we take the derivative of that function, it will have nothing to do with the asymptotic behavior.
But will it have asymptotes?
Yes, because where the function is not defined, the derivative function is not defined. Okay? So where are we? What do we have to do now? We have to do one-sided limits. We have to do 4 one-sided limits. Okay. Limit as x approaches negative 6 from the negative side of, is it x over? It is, isn't it? Now, I'm going to put numbers in this first instance and explain why I would never really do that again. For all intents and purposes, that might as well be minus 6. As x approaches negative 6 from the negative, might as well be minus 6. Okay? This number might as well be minus 7. It's going to be so close that it doesn't really matter. Is anybody confused by that? When in the first number, when I substitute a number that's on the negative side of negative 6, so negative 6.000000001, I'm going to get a negative number, okay, because I'm on the negative side of it, and it's going to be very small. Now, negative 7 times a negative number that is very small is a positive number that's negative, that's very small. Okay? The difference, okay, the difference between 0.000000000000007 and negative and 0.0000000000001 is negligible. Well, it's 7 times, but I mean, okay? So, three negatives make a negative. When we divide any number by a very small number, we get a very large number, which will turn out to be infinity. Now, I know what's going to happen. Some of you are going to do this. You're automatically going to go, well, it's going to be positive infinity. Because you're just going to think, well, one side's negative, the other side's positive. Then you just lost a whole bunch of marks because you're trying to go quickly and you don't really care. But you know, Mr. Hargraft, it's all about showing your work. I don't care about the values of the numbers. I just care about whether they're positive or negative and whether they're very small or not. This will end up being a negative number on the top. On the bottom, we're going to get a positive and very small number because now we're at negative 5.9999999. We're on the positive side of it. Okay? And then this will end up being a negative number as well. Again, the size doesn't matter because we're dividing by a very small number. No, size of anything doesn't matter because we're dividing right here by a very small number. So all the other numbers are irrelevant, okay? The size of them are irrelevant at this point, okay? We end up with, oh, well, it is positive infinity. You just never know. Okay, you guys are probably jumping ahead of me because you don't have to wait for me. You've done one-sided limits before. Okay, we did it in the first unit, didn't we? I don't know. You've probably got review notes on it if you did review notes. Right? Matt McDonald from Bowmanville, Ontario. As x approaches 1 from the negative side, the numerator is going to be a positive number. The first number here is going to be positive. I'm looking at the first number here. Okay? I kept everything in this exact same order every single time. Why? Because if I keep in the same order, I know it just comes in a little bit routine. If you all of a sudden start switching the order around, I feel sorry for you. Oops. When x is a little bit less than 1, in here is going to be a negative number and very small. Have you guys figured out that when we approach from the negative side, there are always negative numbers? Have you figured out that pattern yet? What? Come on, you got to say something. Oh, but you know what? There's maybe 3 people have the same question. You got to ask, please. Yes? 0.999999 minus 1 is a negative number. Okay? Equals negative infinity. Okay, limit as x approaches 1 from the positive side of x over x plus 6, x minus 1. I'm going to go a little bit quickly here because you're probably getting the pattern. We've done one-side limits before, so I guess this is your second kick at the can, so to speak. So, we have the asymptotes. We've got the asymptotic behavior. We're now going to sketch this. Negative 6. X equals negative 6. X equals 1. Please note I've even labeled them. Okay, so as x approaches negative 6 from the negative side, what was that limit? Negative infinity. And then we had positive, negative, and then it's going to be positive. Now, I mean, every time I say, you know, it doesn't alternate, quite frequently it does alternate. Quite frequently it does. But you know what? I guarantee you, test, assignment, exam, oh my God, you know I'm going to make sure it doesn't. Because I'm going to try to track all the people that are just, or try to trap all the people that are like, I'll just go positive, negative, because it has to work that way. Okay? You also have to understand, too, that as we're doing this curve sketching stuff, I talked about the number of pieces going together, and you know, you may be missing a piece, but you know it's there. Right? I mean, you know if you see a tail wagging, you know, and a furry little backside, you know that there's going to be the shoulders and head of a dog someplace. But it could not be. I know. This is so much fun. Okay, so we know what our vertical asymptotes are. Now we do the asymptotic behavior. Limit as x approaches 0 from the negative side of 4 bracket. Is it x minus 3x plus 2? Now, all I care about is whether each number is positive or negative, very small or not very small. Well, 4 is positive always. That'll be negative. That'll be positive, won't it? Okay, because we're just basically substituting in x equals 0. Okay, we're just really basically substituting in x equals 0. And for the denominator, when x is approaching 0 from the negative side, the value of x is going to be negative and very small. And this number will be negative. So when we combine all those things, Amanda, what's the answer going to be? Why is it positive? How many negative signs do you have? 3. 3 negatives make a negative, okay? When you're multiplying and dividing. And guess what? It's going to be infinity, right? Okay? You've gathered that. The answer is always going to be positive or negative infinity. Okay? Sorry to put you on the spot there, but yes. Well, how else are you going to show me that you know what it is? You're going to guess? I can't mark that. What if you're wrong? What if you're wrong? If you're wrong, at least I can give you part marks. And it's the process of you showing me your thought process that I'm interested in too. That you know why it's true. Okay? The limit as x approaches 0 from the positive side of this. The numerator won't change for this. Whoops. The numerator is not going to change just because we're on the other side of 0. But that will become positive and very small, and that will still be negative. Okay? The numerator is going to be a negative number. The denominator is going to be negative and very small. We're going to have with positive infinity. And I know what you're thinking. Oh my God. Negative, positive, negative, positive. Could life be any more boring? X approaches 1 from the negative side. Here's a bit of trivia for you. The lyric, "My life is a boring pop song and everyone's singing along." Nobody? Jack's Mannequin? I know. They're really good, I think. We get a positive number. When x is approaching 1, the middle number is negative, positive. When x approaches 1, this is positive, but that's negative and very small. Ooh. Ooh. It's positive infinity. Oh, Mr. Hargraft switched it up. Negative, positive, positive. That's what we call tricky. Limit as x approaches 1 from the positive side. Now, why does it take so long to teach you guys in the afternoon and the morning goes so much more quickly? Sorry, did you say because you guys are... I thought Crawley was the only one who was awesomer. We had negative, positive, positive, and negative. There we go. Okay?